Casey Howard, Jake Howard, Luke Howard.
Hello, my name is Larry Howard, and I'm here today to discuss power circuit breakers. Have you ever wondered how power gets from generation plants through our distribution lines to our home, and is there any safety devices in between? Today, with our ever-growing power demands and population, it's a bigger strain on our power grid to produce and supply power. One of the main pieces of the puzzle is a circuit breaker. Today I'm here to give you a brief history, the design and purpose, and the trip functionalities of a power circuit breaker. In the early 1900s, the circuit breaker was designed simply to open a circuit and close a circuit. Simply what that means is just like your light switch at home. When you turn the power on and off to light your kitchen, living room, or bedroom. Nowadays, the modern day breaker, around 1950 to 1960, changed. They then in turn came up with a technology to trip the breaker automatically when it sensed an overcurrent state. An overcurrent state is simply where the circuit becomes too burdened with current. So normally, if there was no protection, that breaker would melt down, the house would catch on fire, the cable would melt. So the trip unit is necessary for our protection against house fires, electrocution, death, or just a short circuit state. The purpose of a circuit breaker is very simply an automatic device that stops the flow of electricity as a safety protection device. I have a circuit breaker here with me to help demonstrate that. This, of course, is a modern day trip unit or modern day breaker with a trip unit installed on it. A trip unit, in turn, is a device on a circuit breaker that protects the wiring from overheating in a home. So that being said, I wanted to demonstrate on how this works in the application. In your home, every home has a panel box full of these little circuit breakers. You can have anywhere from 20 to 60 circuits, depending on how big your home is and what you have in it. Simply to state, say your kitchen. You have the power that comes through a generation plant, distribution lines to your home, then it goes to your breaker panel box, where these are your protection on each circuit. So each one of these, your power comes in the line side and goes out the load. The load is simply the light bulb or the hair dryer or whatever you have in that circuit. So very simply, a breaker will close, which closes the circuit, which allows power to get to your load, your light bulb, your hair dryer, etc. Opens, stops the power flow. So as you can see, if you have an issue with your outlet or light bulb, you would want this breaker in an open state. That way you can safely work on that on that item or that device. So with the breaker closed, say you've got a hair dryer and a fan on the same circuit. I can tell you with experience that overloads that circuit, puts a burden on it. That being said, this is a 15 amp breaker. You're probably going to pull anywhere from 20 to 25 on that circuit. Once this breaker sensing that, it is going to trip and open that circuit. That's going to tell you, uh-oh, I don't have power, something's wrong. So what that basically tells you, you need to unplug one of them devices because you're putting too much burden on that circuit. With all that being said, the protection device is called a trip unit. Back to this one, this has what they have called thermal protection. It's got a series of copper components inside that will heat up due to the overcurrent state. Today, on most of your 480 volt circuits and above, that would be amusement parks, malls, department stores. They have 480 volt breakers, which this is called a single pole breaker. They have 3-pole breakers. On the 3-pole breakers, we go with solid state trip units. That is more complex. In its system, it will have what they call sensors, or CTs, current transformers, which monitor the current coming in and through the breaker, and in turn, when it sees an overcurrent situation or instantaneous or a ground fault, it will trip the breaker instantaneous. That again protects you, us, the population from catastrophic events. It could mean just burning the house down, could mean a short circuit state, could mean electrocution or death. With all that being said, I hope today's information gave you some insight on power circuit breakers. These are all engineered daily and kept up with the modern standards and technology to keep us protected on a day-to-day basis. The power circuit breaker is a key part of our power distribution puzzle today, and will continue to be that way as the demands of power continue to grow and technology. I hope this was insightful, and thank you for your time.
Thanks, guys.